everyone. See you again. Now today we need to go to the 5.4. There's a tutorial and including the 5.5. 5.5 just a short notes only. They don't have any important things, just common sense. So today we need to finish is chapter 5 lah. So make sure you take out the notes and also the tutorial 5.4. So I will give you the answer. Okay, now we're going to see the tutorial answer. That's the objective. Question 1 until question 11. So I just write the answer here. If got anything you want to ask, you can text me and snap the photo to show me actually which one question you want to ask. Okay, I want to go is a structure question. Okay, let's see the first structure question. There's a question 12. Okay, let's see here. Nuclear reaction is represented by the following equation. So I give you all the equation here, uranium and neutron. After bombarded, they produce with the 2 lighter nuclei and do know how many neutrons. Okay, plus energy. So from here, this one is all information for the mass, atomic mass they told you. Okay, now, what is the value of the X? So we just count the proton number. Excuse me, because proton number not related, we count the neutron number only. 235 plus 1 is a 6, 236. Then this one 141, this one's 93. Okay, after plus together, you left how many? So my answer here is 2. Okay, you left 2 neutron. Okay, now can you name the nuclear reaction involved? This one is what nuclear reaction. Can you see the bigger size split becomes smaller size? So this one is a nuclear fission. Okay, now we go to number 3. What's the meaning of nuclear reaction in B? Just now you mentioned nuclear fission, is it? What's the meaning? So that means you need to explain. There's a heavy nucleus. Then after that, bombarded, okay, by the 1 neutron. After that, they will split into 2 lighter nuclei and 3 neutrons. Okay, that one is a nuclear fission. Okay, the splitting of the heavy nucleus in the 2 lighter nuclei and admit either 2 or more neutrons. After that, okay, one more, I forget already, there's a large amount of energy. Okay, you must add the word large amount of energy. Okay, then we go to the next one. State the application. Okay, application, we using the nuclear fission. Okay, where we use it, we use in the nuclear power station. Okay, this one is important, we're using the nuclear fission. Okay, now you need to calculate the energy release. Okay, energy release. So that means, okay, I explain first. Energy release means you need to calculate this one, the mass defect first. Okay, this one, the mass, total mass, how many? Then you minus the total mass. Okay, I highlight first. Okay, this one is a before. Okay, before is here. So total mass here is how many? You go to plus first. Then after that, you need to minus another. Wait, I change the color. See, can change or not? Okay, no. We just write here. Okay, so this one is after. This one is after means before minus the after mass. Okay, one more thing to remind you. Please don't cut the decimal point. Use all decimal point. Okay, before minus after. Then you got U, is it? Final, you help me to convert the U become kilograms. So you find the mass defect. After you find the mass defect, then you need to find the energy, is it? So energy E equal mc square. Okay, so from here, hope you are finished. So I just show you the calculation for the mass defect first. Okay, this one is a mass defect. Okay, can you see the full? I'm using full number. Okay, I never cut anything. So after minus, I get it 0.19405 U. So this one U, I need to convert become kilograms. So I multiply 1.66. Okay, times 10 power of negative 27. So I get it, this one in my mass defect. Okay, after get the mass defect, then I need to find our energy, nuclear energy, E equal mc square. So I take this part, then times 10 power of 8 square. So I get 2.899 times 10 power negative 11 joule. Okay, so this one is how to do the calculation for nuclear energy. Okay, the numbers so long already, so when you just press the calculator, please you press carefully. Okay, the next one is a power. Okay, remember power, what's the formula? Power is the energy over the time taken. Okay, let's see here. Here is what time taken. The time taken is a micro. Okay, remember micro? Micro is 1 times 10 power of negative 6. So from here we take the just now answer, energy, nuclear energy, then you divide by the time taken. That one is a power. So the answer is 2.899 times 10 power negative 11 over microsecond. 5 times 10 power negative 6. So this one is your final answer in watt. Okay, power is in watt. Okay, so this one is a question 12. Then the following is a question 13. Okay, let's see the question 13. There are two tables. Okay, table A, they show about the reaction, the total atomic mass before and after. Okay, let's see, this one is nuclear fission. Okay, they count for you already. This one is before, this one is after. So if you want to find the mass defect, you take the before minus the after. So this one is a nuclear fusion. So this one is a before, this one is a after. Okay, so this one is what they want to show you lah, what's the info lah. So now I want you to see the first one. What means by nuclear fission? Again, just now already got this one question, is it? So nuclear fission is a heavier nucleus splitting by 2 lighter nuclei. Okay, after that, the 2 lighter nuclei also will come out 3 neutrons. Then after that, large amount of energy. Okay, so from here we just start nuclear fission. Okay, there's a splitting of a heavy nucleus into the 2 lighter nuclei. Then also emit 2 or more neutrons and large amount of energy. Okay, now we go to the second one. Okay, second one I highlight here. Okay, underline, so I highlight again. Okay, using the info from the table, you need to compare nuclear fission and nuclear fusion. Okay, from the table, what we can compare? Okay, first one we compare the mass defect. Okay, after you minus nuclear fission, the mass defect how many? Then the mass defect for the nuclear fusion. Then after that, you also can compare the energy. Which one energy bigger? Which one energy smaller? Okay, when you know the mass higher, sure the energy is biggest. Because energy is directly proportional with the mass defect. Then your speed of the light is constant. So from here, after you do the comparison, you make relationship between the mass and energy. The relationship should be directly proportional lah. So from here, we do the calculation for the mass first. Okay, table A. Okay, table A, the mass defect 0.2025. Okay, when convert become kilograms, this one is the answer. Okay, this one is mass defect for the nuclear fusion. Okay, fusion is the 0.0197 U. Then convert become 3.32702 times 10 power negative 29. Okay, now excuse me, you all write your attendance in the Google Classroom. I already create there. Okay, not just at the Telegram. It's Telegram, that means so many notes, then later you can miss it. So better you write inside your Google Classroom. Okay, now we can do the comparison. The first one, comparison for the mass defect. Nuclear fission, they produce they will lose. Okay, they will lose more, they will reduce more, is it negative 28? So that means the mass defect for the nuclear fission is higher than nuclear fusion. Okay, the second one, energy. amount of energy. Amount of energy from the nuclear fission is more than the nuclear fusion. Okay, now we need to do the relationship. So that means as the mass defect increase, energy release also increase. Or you write directly proportional, but you need to write the full sentence. Okay, let's see the answer. Okay, nuclear fission has a bigger mass defect. Nuclear fission also produces higher nuclear energy. So from here, the bigger the mass defect, the larger the amount of energy produced. So this one is a relationship. Okay, now we go to number C. Okay, C, they ask about the nuclear fission, they produce a chain reaction. Okay, describe how the chain reaction happen in the nuclear fission of the atom uranium. So this one, that means you need to explain more than one of the nuclear fission. Okay, explain more than one of the nuclear fission. Okay, example, first step you say about nuclear fission. A heavy nucleus that split into 2 lighter nuclei and produce 3 neutrons, okay, and large amount of energy. Then after that, the large amount of energy and the 3 neutron, what happened? 3 neutron will continue to find another 3 uranium. Then another uranium will start bombarding again, then produce more of the lighter nuclei and create the neutrons again. So the process will be repeated. After that, they produce large amount of energy. So this one is a chain reaction. That means the parents decay become the daughter. After decay become the daughter, they're still unstable. I mean, they continue to decay until granddaughter to come out already. So that means now I show you the answer. First one, when a heavy uranium is bombarded by the fast-moving neutron, they will split into 2 lighter nuclei, 2 or more neutrons, and large amount of energy produced. This one is the first step. Okay, let's see the second step. Another 3 neutrons will continue to bombard with other 3 heavy nucleus and produce new neutron and large amount of energy release. So last one, number 3, the process will be repeated. So these 3 things just explain about the chain reaction. Okay, so this one is a tutorial 5.4. Okay, so hopefully you can check it. So now I want to go is a chapter 5. Chapter 5 just a simple, we don't have any calculation, just a knowledge. Okay, now we're going to see the chapter 5. Okay, first one, they say the important proper management, how we go to manage a radioactive substance. Okay, let's see example. This one is a background radiation. Okay, you never face any alpha beta. Actually background. Okay, normally we say a background reading, is it? This one is a background reading. Okay, surrounding with you, we also got the radioactive. But the harmful still very low lah. You see 51% from the gas, then the rock, cosmic, nuclear leak, then medic, food also got. Okay, let's see the negative effect. Okay, let's see the negative of the radiative substance. Okay, when the radiative emission strike living cell, that can cause about ionization. Remember the ionization with the molecule? Okay, that means the molecule now in your body, that means cell lah. This may cause about the cell to be killed, resulting the tissue be damaged. Okay, let's see the factor. The factor how to count about the radiation is high or low. Okay, depend the factor. We not every time your kernel is 100%, no. So we see how the dosage they put inside your body. Okay, first one we say the type of the radiation. Sure, we got alpha, beta, gamma, different type, different effect. Okay, after that we got dosage. You put how many half-life. Okay, you put how many quantity, then they stay how long. That one is a exposure time. Okay, 3, method. Injection into your body. Either you want to take the medicine, either you go to injection. This one is a different of the factor to affect your body. Example, you go to operation. This all thing is a different. Okay, now 4 is the exposure of the different part of the body. different part of the body also can get the different quantity of the radiation. So this one is a 4 factor, the affecting, okay, the severity of the radiation. Okay, now we go to next one, the harmful. Okay, let's see the harmful effect. Okay, on the human can be divided to 2 categories. Okay, let's see the first categories. There's a somatic effect. Okay, somatic effect that appear in the person that exposed to radiation. Okay, the seriousness of the effect depends on the dose, depend on the dose of the radiation received. Now you see the somatic. What's the somatic they're talking about? Okay, all part of the body that will damage. That means somatic effect means every part for your body that will damage, but except reproductive organ. That means that do not affect your reproductive organ. So now we're going to see the example somatic effect. First one, radiation burn. That means it will cause about your skin burn if you get more of the radiation. Number 2 is a fatigue. Fatigue means you're very tired. Okay, nausea. Nausea means you don't want to eat, you want to vomit. Okay, then the D, you got hair loss. Okay, leukemia is for your leukemia is for the white blood is more than the red blood. Okay, cataract is for your eyes. Can G, vomiting. After that, infertility for the male. Okay, fertility for the male, I never say female. Okay, after that, the organ failure, organ cannot function. Then the last one, dead lah. Okay, so this one is long time you're exposed to the radiation. So this one is a somatic effect. Now we're going to see the genetic effect. Okay, genetic effect that appear to the future generation. That means they do not affect for yours. They affect for your coming generation. So that means maybe now you're exposed to radiation. Okay, now you're okay. If nothing happened. Maybe your son. Okay, maybe your son, they got problem already. So this one is radiation that will damage reproductive cell. Okay, they will affect the generation. Example, we got chromosome abnormality. Example, you say Down syndrome. Okay, why the baby Down syndrome? Why that one don't have? This one got? Maybe lah. This one is we do know. We cannot be explained. Okay, after that, maybe the birth defect, maybe the congenital defect. So from here, we got Down syndrome, we got Klinefelter syndrome, we got Turner syndrome. Okay, Klinefelter syndrome is for the boy. Okay, for the guy. Guy normally is a XY, is it? For Klinefelter is a XXY. That means you extra one X. Okay, that means you say that one is aqua lah or pandan lah, like this lah. Okay, another one is a Turner syndrome. Turner syndrome is for the ladies. Ladies XX is it for the sex chromosome. But this one Turner syndrome, they just got one X only. That means they less one X. So this one the hormone for the ladies become less lah. So you find it just like the characteristic, just like the tomboy. Okay, this one is a Turner syndrome. Okay, after that we got premature death. After that we got cancer in the later life. So this one is different with the somatic and genetic. Okay, now we go to following. Okay, following I don't want to explain it. They've got so many. This one just your common knowledge about how you precaution with when you're handling about the radioactive. So we see the simple one where the eyeglasses made by the lead when you're handling with the radioactive. After that, using the shielding such as the lab coat, this is all you want to cover. Okay, after that, keep the exposure times as short, then radiative keep into the thick lab container. Okay, these all where the film blatch. Okay, film blatch. Okay, after that, when the radiative material are used in the medic, okay, with the short half-life chosen. So this whole thing is about the safety. Okay, now I want to see is how to do the management for the waste. Okay, the extra one never use one, where we want to solve it. So the first one, they say radioactive waste that consists of a variety of the material requiring different method of the management to protect people and also environment. Okay, let's see we separate by 3 parts. First part is low level waste. That means the radiation is low effect lah. Low level waste example, they come from where? Hospital, nuclear power station, or lab, and also industry. So this one is an example. After they're using all the clothing, all the glove, all the paper, this all how they want to manage. Okay, first one, we know this all is a short half-life. So what we need to do the management, solid the waste are stored in closed container. Okay, any closed container, buried in the shallow landfill site. No need so deep, just a surface. They put some soil come out, then put in under the ground. Okay, this one is when you manage a low level waste. Okay, then we go and see the medium level. Medium level how? Okay, medium level high a little bit quality lah. So from here, this one from the nuclear power station, from the lab industry. Okay, this one chemical sludge. So where we go to manage, half-life already is a long. Okay, we also say we need to solidify in the concrete, or you say putiment, and also buried underground, not surface only. You need to underground. Okay, more deeper. Okay, next one is a high level. High level, they come out from the nuclear power station. So this one they use the fuel rod, boron, liquid waste from the fuel. Okay, reprocessing. Okay, half-life sure is a long one. Sorry, it's a long one. Then after that, how we go to manage? First one, you see the procedure so many. You need to submerge in the pool of water because you want to cool down first. Okay, cool down, that means you will affect the thermal equilibrium. Okay, after cool down, what happened? Then you need to store inside the steel container, either steel, either lead box. Okay, after you put inside the container, lock ready, then you need to some more bury deep under the underground. Okay, you need to bury it deep, not surface, deep some more. Okay, cool down, put inside the lead box, then bury it deep underground. This one is for the high level waste. Okay, high level waste. Okay, now we go to the, I think no more already, is it? The last part just a manage only. Okay, now we go to tutorial. Okay, let's see the tutorial. We straightforward to finish it. Okay, we answer together. Okay, which of the following is a hazard symbol for the radioactive substance? Sure, this one. For the hospital, you can see this one, X-ray, and also the other radiation room. You can see this one symbol. Okay, now number 2, which one following factor is not affecting the severity of the radiation? Just now we learned about 4, is it? Type, yes. Dosage, yes. Method of injection, yes. The temperature of the radiation source, no. We're not related with the temperature. Okay, number 3. A worker at the nuclear plant walked into the room and is accidentally exposed a small amount of alpha radiation. On entering this room, the worker will, what happened? They suddenly go in. Then kena a small amount of alpha. The alpha or beta or gamma. Small number of gamma radiation. So what happened for the workers? Okay, the answer is, okay, so from here you say very hot, no effect, get the skin blister, lost consciousness. Which one should be the answer? The answer is feel no effect, because just a while only. Just a while actually is nothing happened. Okay, unless you are long time to expose. So this one I told you already, exposure time is one of the effect. If you just go in, you kena a little bit, you come out, is nothing one. Okay, then we go to number 4. When some fresh of the food are exposed to gamma ray, the food keeping quality are improving, the food are safe to eat. Why can people eat those food without suffering from the effect of the radiation? Why? They put gamma, is it? The preservation, you buy the Maggi mee, why we can eat? So the reason is gamma ray have a very short half-life. So that means they put inside, after that short half-life, then they will finish. Okay, then we go to the number 5. Which one following is a not safety precaution when you want to handling the radioactive substances? Okay, use a forceps, yes. Don't use your hand, use a forceps. Keeping the exposure time as long as possible. Is it yes or no? The answer should be B lah. You want to exposure as long as possible. So that means the answer should be B. That's a not safe. Okay, we check C. Radioactive substance are kept in a thick lead. Okay. Donkey, keeping the large distance between the person and the source. Yes. So B is not a safety. Okay, number 6. The container used for storing the radioactive waste must be lead box. Okay, must be lead because the gamma can be blocked by the lead box. 7. Why are the radioactive source stored in the box line with lead? Why we want to put inside the lead box? Okay, lead absorb the radiation and stop it from escaping into the room. Yes or no? Suppose this one is the answer lah. We're going to check the B and C. Lead absorb the radiation source and make it safe to handle. Not safe to handle. They just want prevent they go out. C. Lead can slow down the rate. With its radioactive source, they cannot the lead. Okay, slow down the rate is a moderate. Remember, there's a graphite. Okay, D. Lead completely stop the source from decaying and also so it lasts longer. No. Okay, this one not the lead box function. So the answer should be A. So that means until here we are finished the whole chapter 5. Okay, thank you for your watching. So from here you can check about your 5.4 tutorial and also the short question from the 5.5. Okay, so everyone, wait okay everyone, so from here we have finished our chapter 5 already lah. So chapter 3.3 we also complete about the tutorial, so that means the coming soon should be 3.4. okay, 3.4 and 3.5, then we complete the chapter 3, then the last one is left chapter 4 only. So when you come back to school, I think the chapter 3 still not yet finished lah. We still got small part for chapter 3. Then we still got how many months? Trial, we still don't know what's the time. So that means we continue with the chapter 4. Then finish. Then we start the revision. So hopefully you can continue to study. Homework, please finish it. So many subjects now. You need to rush your homework. So we'll see you soon when the school just open. So student, please ready, ready all the thing. Okay, don't play already. You must be serious because your SPM is coming soon. Okay, thank you for watching. Make sure you go to take your attendance in the Google Classroom. Okay, thank you for your watching.